Well, this video is for the second half of section 2.3. It's the same types of problems, although in these problems we're only being asked one question, where is it greater than, or where is it less than, rather than being asked both questions. So let's just look at a couple of these problems. Problem 10, and these are on page 99. Problem 10 says x cubed minus 7x plus 6 greater than 0. So, just like we did before, what we want to do is graph this, minus 7x plus 6, and see what it looks like. In the standard window, this is pretty straightforward. It does go off the screen a little bit, but it comes back, and it's pretty easy to see what's happening there. Okay, so let's go in and find the roots. Now, if you look at the roots on this, it does seem to be going through some of these whole numbers. Okay, you can see how it kind of looks like these are going, the roots are at the whole numbers. So if you want to, you can go into the table, which is second graph. So you got to hit that second key and then hit graph, and that will show us the table. And you can see right there, when x is negative 3, y is equal to 0. Let's see, where is it? Right there. And then over here, when x is 1, y is 0. When x is 2, y is 0. And so if we go back to the graph, that's what we're seeing. So those are the roots. Those are on the whole numbers. Okay? And so we don't have to go through that process of finding these roots. Okay? We can read them off the table if they're whole numbers. So that one's negative 3. This one's positive 1. And this one's positive 2. Okay. So the problem is asking us where is y greater than 0. So right here and right here, this is where the y values are positive. And so the intervals that correspond to that would be there and also over here. So our answer would be x greater than 2 or x less than 1 but greater than negative 3. Okay. So, that is a pretty straightforward problem there, number 10. Let's look at a couple more. All right, let's see here. Let's look at problem 14. This one is x to the 4th minus 5x cubed plus 20x minus 16. And we want to know where is that going to be greater than 0. Okay, so again we want to get a graph of this and see what it looks like in the standard window. Okay, well this is not too bad. It comes down, and then we do kind of lose the loop there, but it comes back pretty clearly. So it's, you can see this big W shape that I was talking about earlier. And this one also kind of looks like we've got roots on the whole numbers. So let's see here. Let's get a look at that. So there's that big W. And you can see it looks like those roots are on whole numbers, negative 2, positive 1, positive 2, and positive 4. So let's look in the table. So if we hit second graph, then we'll see the table. And there it is, yeah. When x is negative 2, y is 0. When x is 1, y is 0. And then 2 and 4 are also roots. All right, so again for this one, we don't necessarily have to use that root finder function to identify these. So let's see here, negative 2, positive 1, positive 2, and positive 4. Okay, so now we've got the roots identified, and now we want to look at where is the function greater than 0. Where is y greater than 0? So there's 3 regions where that's happening. Okay? This region here, that corresponds to these x values, and you can see that in the table as well. Let's see. Take a quick look at that. So if we call up the table, then you can see that out beyond -2 for these values here, see how these values are positive. And then here these y values are negative. So that's what we're looking for. If you ever have trouble, I'm just talking about different ways to get at the same idea. Where are the y values positive? You can see it on the graph, and sometimes you can see it in the table as well. All right, so the other intervals are here and also here. So our answer would be x less than -2, or between +2 and +1, x less than +2 but greater than +1, or x greater than 4. So we've got 3 separate intervals, and we use 3 separate inequalities to represent them. Okay, so that's problem 14. Let's look at 2 more here. See here, problem 16 is also a 4th degree equation. X to the 4th minus 6x cubed plus 2x squared minus 5x plus 2 less than or equal to 0. So we'll go ahead and graph this one. 6x cubed, 2x squared, minus 5x plus 2. And again, I encourage you to double check what you've typed in just to make sure that you didn't hit a button there. Okay, so let's look at this in the standard window and see what it looks like. Okay, well this one kind of runs off the screen and looks like this. I suspect that what's happening there is that it's looping like that, and so that's what the graph would look like if we dropped our y minimum down far enough to see that. Okay? Really what we need to do here is we need to find out what these roots are here and here. Okay? You can see the y's are positive here, and the y's are negative in between those 2 roots. So let's go ahead and find out what those roots are. See here, they're not whole numbers, so we won't see them in the table. Let's see, this one is 0.394 approximately. And then the other one, .793. Okay. So this one is a pretty simplistic curve. There's not a whole lot going on. There's really just one region where the y's are less than or equal to 0, and it's right there. So we would say x less than or equal to 5.793, but greater than or equal to 0.394. Okay. Well, let's see. Let's look at the last one in this section, problem 18. This one is a 5th degree equation. This will behave more like one of those cubics than it does like the parabolas or 4th degree equations. So let's get this graphed and then we'll see what it looks like. Okay, let's see here. So, x to the 5th, 5x to the 4th, 4x to the 3rd, 3x squared minus 2. And again, when you're typing all this in, I always think that it's a good idea to double check that. All right, so let's see what it looks like in the standard window here. Well, this one is kind of straight up and down, and then it kind of seems to come back and do this. Okay, so it looks like it is looping over there a little bit. All right, let's see here. I'm debating about whether or not I want to change the window to get a better look at this, but it's clear that the y's are greater than or equal to 0 up here, less than down here and over here. Okay, so it's this area off to the left here where the y's will be less than or equal to 0. And again, you can see that in the table as well. So I think the first thing I'm going to do is try to find out what that root is there. 6. So it's right out by -6. When the graph is straight up and down like that, this is a good time. This is a place where I frequently type in the left and the right bound. So I'll go ahead and find this. I'll type in -7 as the left bound, -5 as the right bound, and let the calculator do the work for me there. Let's see, -5.780. And I just wanted to point something out that the calculator sometimes does on these problems. And this is, we're looking for the root, which is the place where y is 0, and people sometimes get flustered here because you can see down in that right-hand bottom there, it says y equals 8e minus 11. Whereas when we find the other roots, let's see if I can quickly find one of these other roots here. Well, not so quickly. There it is. Okay. You can see it says y equals 0. Okay. So what's happening there? Let's see. What was that root? -0.552. So let's go ahead and put that on the graph up there. Okay, so let me just talk briefly about what the calculator was showing you when we found this root. It said y equals 8e minus 11. So this is how the graphing calculator expresses scientific notation. This means 8 times 10 to the minus 11th power. So a very, very, very small positive number. Okay, and so what it's saying is that we're looking for y to be 0, and it's saying, well, at this point, I got y to be this number. Is that close enough to 0 for us? If it's not, there are other things that we can do. For our purposes, this is fine. Okay, so if you see that when you're finding roots on the calculator, don't worry too much about it. Let's see. Okay, we got to find that last root. Over there, looks to be just about +1, but not quite. What is that? 0.772. Okay, so we've identified the roots. We can see where y is positive and where y is negative. So let's see, where is y less than or equal to 0? Oh, I forgot to write down the number for this one, 18. Okay, where is y less than or equal to 0? So x less than or equal to 0.772, but greater than or equal to 0.552. And then over here, or x less than or equal to -5.780. Okay, so that's it for this section 2.3. I think we're going to skip section 2.4 and just go on into 2.5 and so on. Okay, section 2.5 is actually very short, but it does come in handy when we get into the end of chapter 2. So I'll talk about that more later, but this will wrap things up for this part of chapter 2, and then I'll do some more videos for the second part of chapter 2. If you have any questions, please send me an email and we'll see if we can get things straightened out. Thanks.